So let's look at some past exam questions. So here I have one from the 2018 Northern Hemisphere Exam 1. It's a question 3, so easy to middle of the range difficulty. We have triangle PQR shown in the diagram below. You can see we have two sides and the included angle. So with that we know, okay, cosine rule might come into play. The length of side PQ is 12 centimetres. The length of side PR is 5 centimetres. Angle QPR is 100 degrees. The perimeter of triangle PQR in centimetres is closest to. So here we've got to figure out this angle here, this side here, and then because we've got to find the perimeter, we add it all up. So let's write out the cosine rule from our formula sheet. I always have to look at my formula sheet for this one, even though I use it all the time. It's just one of those ones. Okay, so a squared equals 5 squared plus 12 squared minus 2 times 5 times 12 times by cos 100 degrees. A squared equals, alrighty, 5 squared plus 12 squared minus, now in an exam you probably, or you may or may not write this out, it's up to you. I write it out to help clarify it for us all, because I'm switching between, two screens. Makes life difficult. Control Enter. So that's a squared, remember, 189.838, and then we've got to find the square root, so control that, and then I'll arrow up, grab that down, enter. So A is 13.78. So now we've got to add up our three sides, So A, B, and C. Okay, so 13.78 plus 5 plus 12, so 30.78, 30.78, and it's closest to 31E, and yes, that's correct. So now we're looking at 2017 exam 2, so this is the extended response. This is question 3. So we've done 2 questions, and remember in all our exams the questions get harder as we go along, or considered more difficult as we go along. So the hostel buildings are arranged in a grassed area, but the grassed area is shown shaded in the diagram below. So you can see, here's a circle, there's a square, there's a triangle there with an angle there. We can see, okay, the radius of that circle is 50 meters there, like that. The grass area is made up of a square overlapping a circle. The square has side lengths of 65 meters. And the circle has a radius of 50 meters. So in knowing that the square has side lengths of 65 meters, we know that that is 65 meters. And because that triangle goes from there to the outside edge of the circle, so that those side lengths are the radius. The angle is also shown on the diagram. use the cosine rule to show that the angle correct to the nearest degree is equal to 81 degrees. So this is a show that question, so you have to show the calculations here. That's what they're asking you to do. They've also specified that you have to use the cosine rule in order to show it. So here they are really asking for you to show that you know what the cosine rule is and how to use it. So again, let's write this out. So we are finding an angle here. So that's cos A equals b squared plus c squared minus a squared divided by 2bc. All right, so like substituting our knowns and unknowns. Okay, so cos theta is the angle. Now, side A is that length there, which is 65 meters. So that is 50 plus 50 squared minus 65 squared divided by 2 times 50 times by 50. So cos theta equals, get my calculator, 50 squared plus 50 squared, take 65 squared over 2 times 50 times 50. Okay, so that's 0.155. So theta equals inverse cos 0.155. So theta equals, okay, let's get this back up again to just double check. And we can just arrow up, grab that down, control enter, and yes, equals 81.0832. And so, yes, theta equals 81 degrees. Now, 56% of the state got 1 mark there, 44% of the state got 0. And their statement here is most students were able to write the equation. So they were able to write the equation, but some made errors in the rule by placement of a 65 where a 50 should have been, or vice versa. So a lot of students here, in my reading of this, instead of having 65 here, they had 50. They didn't identify that because the angle we're interested in is here, that's angle A, that must be side A as well. Okay, so we have to have the two of those together. So from the 2019 exam 2, a question 3 again. The diagram below shows a cargo ship next to a port. The base of a crane is shown at point Q. So we have this diagram here with two sides. There's 20 meters there, 38 meters there, and the angle between them is 120 degrees. So the base of the crane, the bottom of the crane, is 20 meters from a shipping container at point R. The shipping container will be moved to point P, 38 meters from Q. the crane rotates, turns 120 degrees as it moves the shipping container anti-clockwise. Now, anti-clockwise, you imagine the clock like that. So anti-clockwise is then going in the opposite direction to the way a clock travels. So a clock, usually the hands travel around in that direction. Anti-clockwise is then that direction. So this boat is going to be moved in that direction here. It's being moved from R to P. What is the distance RP in meters? What is that distance? Okay. Round your answer to the nearest meter. All right, so this looks complicated with lots of things going on, but what you really have to remember is this is just a triangle. Okay, or after all of that, it really is just a triangle. You don't have to rewrite it, but I'm rewriting it. It's just a triangle, and we want to figure out that side there. Okay, so we have two sides and the angle between them, and we want to figure out an unknown side. That's cosine rule. So let's write out the cosine rule, and we're finding a side. So that's a squared equals b squared plus c squared. Take away 2bc cos a. Okay, so a squared equals, so that's 20 squared plus 38 squared. Take away 2 times 20 times by 38 times by cos 120 degrees. So 20 squared plus 38 squared. Take 2 times 20 times by 38 times by cos 120. I'll pop in the degree sign. Control Enter. So a squared equals 2,604. So that means the square root of that is 51.0294, and our rounding information is to the nearest meter. So, and it's RP equals 51 meters. Okay, yeah, 56% of the state got 1 mark there. And their statement just was, this question was reasonably well done. So this was what they were basically expecting, this type of working.